All right, welcome back from spring break, people. Hope everybody had a relaxing time, got to sleep in, but we got to get back to work, even though we're not getting back to school. But in any event, we are in the area unit. We left off with areas of kites and rhombi. I'm going to review the different areas that we did, along with teach you some new information as well. So let's see. We are partially done these day 3 notes. Again, we are in the middle of circles right now, but the objective for the day is to be able to find area of something called sectors of circles. And I'll explain what that is. So kind of review of where we left off, since you did have a week off. Again, we looked at parallelograms, which remember were just base times height, where base and height had to be perpendicular. So here's the perpendicular on this parallelogram, which means that this I'm going to use as the height. It would be perpendicular to this base, which is 8. So base is going to be the 8 times the height, which is 10. So the area on that is 80. Triangles, remember, were just half of a parallelogram. So it would be half the base times the height. Base and height still need to be perpendicular. I see a perpendicular right there, making the 6 the height and this the base. So again, be 1/2 the base of 10 times the height of 6. So again, I'm going to multiply those. Half of 60 would be 30. Then on the trapezoid, that was a complicated one. That was what, 1/2 the height times base 1 plus base 2. Base and height still need to be perpendicular. I noticed the perpendicular right here. That means that 6 is going to be the height. So let's see, 1/2 the height, which is that 6. Then the two bases, they are these two sides right here, the 8 and the 5. So I'd add those together. So when I add that up, that's what, 13, and then half of 6 is 3. So it'd be 13 times 3, which is 39. So that'd be the area on that. Then the kites and rhombi, remember they had the same formula. That's why we kind of did them at the same time. Formula on those was what, 1/2 the diagonals around D1 and D2. So in this one, I have a kite. Remember that the long diagonal of a kite bisects the short one. So if this half is 4, that means this half over here is 4, which means this whole diagonal is 8. This whole diagonal is at 12. So the area on this would be 1/2 of 8 times 12. And that's going to be what, 48. Then where we left off was the circle. Remember the area of a circle. Well, this is the definition of a circle. Again, you should already have this in your notes. We're going to finish the notes today. Definition of a circle is a set of all points equidistant from a single point. That single point being the center. So again, here's the point. That equal distance that they're talking about, that is your radius. Remember the formula for the area of a circle was pi r squared. Then we did for problems using area of a circle. Oh, sorry, I don't think I got that on there. Again, it's the set of all points equidistant from a single point. Again, that distance is the radius. The area formula is pi r squared. So down here, again, we already did these problems. Area of a circle with a radius of 12. Again, if I use the formula pi r squared, it gives me the radius. So I would do pi 12 squared. So that's 144 pi. And that's inches squared. So remember that this is an exact answer. If it asks for a rounded one, you'd actually use the pi button on your calculator. So to do that, I would do 144. The pi button, you can see it right here. I have to hit the second button to get to it. And so if I rounded that to the nearest tenth, that'd be 452.4 inches squared. So there's more problems. We did those in class, but I was just getting you used to that. So that's the circle, area of a circle. All right, a sector. We're going to look at a sector today. So a sector, this is an area bounded by 2 radii and a portion of the circle. I like to think of it as a slice of pizza, because I like pizza. So again, it's an area bounded by 2 radii. So here's one radius, here's a second radius. And then the portion of the circle is basically the crust of that pizza. So that's the picture of a sector right there. Again, I like to think of it as a slice of pizza. But it's always going to have an angle measurement associated with it. And that would be this angle in here. So now the formula to find the area of that, we need to use that angle. And what you do is you put that angle over the whole circle. The whole circle in degrees would be 360 degrees. And then it's a fraction of the area, which is going to be pi r squared. So I also like to think of this as a fraction of the area of the circle. This fraction is coming from the angle measurement over 360. So this is a fraction of the circle. So let's see if we can use it. So here it wants me to figure out the area of this slice of pizza. I have this 83-degree angle to work with. So the way you use the formula again, I'll put the formula up here again. Area is equal to x, which is the angle measurement over 360 times pi r squared. So the x in this case is going to be that 83 degrees. So I'm going to do 83 degrees over 360. And then multiply that times pi r squared. It looks like I don't have a radius on this. So I'll just give it a radius of like 5. So I do pi 5 squared. Looks like I didn't put a radius on all these, so I have to go get these radii then. So now what I would do is I go to the calculator and probably just kind of plug it in like that. So first of all, I figure out what 83 over 360 is. So it's equal to that. So now we just use that number. And so this 83 over 360 is the same as that. And now I need to multiply by pi 5 squared. So I would just do times. And you can do pi 5 squared, or you just do 5 squared is 25. So we could do times 25. And remember to hit the pi, have to hit that second button. So then I would just hit enter. This is going to be a rounded number to the 10th, 18.1. So that's an example of a sector problem. Another sector problem would be down here. I have a central angle there, or that angle's at 148. I still need a radius on this. I'll just give it a simple radius of 6. Again, I just mistakenly didn't do that. So now when I use the formula, remember it's x over 360. X is always the angle measurement. So I put 148 over 360. And then I multiply that times pi r squared. Radius, remember I just gave it the 6. And then go to the calculator. So again, on the calculator now, I would do that 148 over 360. And then I need to multiply that times the area of the circle, which is this pi 6 squared. So I would do times 6 squared is 36. And then put the pi in by hitting the second button and hitting that button. Hit enter, and so you can see you're at 46.5. Down here, one last one, but notice that this time the slice of pizza isn't shaded in. It wants me to figure out all this other area. Well, all this other area, I'd have to get this angle right here. Well, remember from like skateboarding or snowboarding, when those guys spin in the air completely one way around, they were going 360 degrees. So to figure out what this angle is, I can do 360 minus that 65 because it falls short of the whole way around. So I would do 360 minus 65, and that's 295. So this is 295. So that would be my x. So the area of this sector is going to be 295 out of 360. Times pi, they didn't give me a radius, so I'll put a radius in here of 8 just to show you another example. Again, I mistakenly didn't put radii on these problems. I apologize. But it would be pi 8 squared now. Again, I go to the calculator at this point, and I would do 295 divided by 360, figure out what that is. Then I need to multiply that times pi times 8 squared. So it would be times 8 squared is 64 pi. So I end up with 164.8, we'll call it. So 164.8. So that's how you do these sector problems. Again, it's using pi r squared because it is the area of a circle, but it's not the whole circle. It's a fraction of the circle. The fraction can be found by taking the arc or the angle measure and putting it over 360, and then multiplying that times the whole area, which will give you just the area of the slice of pizza. So some practice problems I want you to try on that. We'll see how you do on that. Again, you're going to turn those in as homework any way you can. And as always, if you have any questions, you can email me. Again, I'm going to have office hours that I mentioned in that update, or you can come and see me during those office hours, and I can help you with those as well. All right, I'll talk to you then. Thank you.